In this video, I'm going to be doing a brief tutorial on what are sequences in series. We're going to define them. We're also going to evaluate sigma notation. Now, for those watching, I apologize. I don't have my normal equipment for making this video, so it may be a little bit rough. So first of all, we want to define a sequence. A sequence is an ordered list of objects, and by objects here, we mean numbers. Now, when we're looking at a sequence, looking at these lists of objects, what's really important is that these objects have a pattern. So let's add that follow a pattern of some sort. Now, it doesn't have to be really obvious. It could be you're adding 1 every time. It could be you're adding 2 every time. It doesn't really matter what the pattern is, it's just that there is one. Now, each object, by object, again, we mean number. Each number is called a term. So a term in a sequence is just a number in the sequence. Now, with sequences, we have two different types. We have this thing called a finite sequence, which simply means that it ends. So like this one here, I have 1, 4, 9, 16, 25. Now, the pattern here is that these are all perfect squares. 1, 4, 9, 16, 25, and so on. This one here is an infinite sequence, and we see the dot, dot, dot at the very end tells us that it goes on forever, meaning that this pattern will continue. So for example, in this pattern here, I'm adding 1 from 1 to 2, I'm adding 2 from 2 to 4, I'm adding 3, then I'm adding 4. So I can imply that the next one here, I will add 5 and continue on. So an infinite sequence goes on, it doesn't stop, whereas a finite sequence does. Now, a sub n here. A sub n simply means the value of the nth term. Now, n comes from natural numbers, at least that's where we're defining it from, and those are our counters. So the first term, a sub 1, would be our first one, and then a sub 2, and so on, would count which term it is in the sequence. So for example here, I have the sequence 1, 4, 9, 16, 25, the one we mentioned above. And so it says if n equals 4, meaning I'm trying to find a sub 4. So that would look like this, so a sub 4, but it would be much smaller, so it would look like that. So a sub 4, in this case, I'm just counting what is the fourth term in the sequence. So I just count 1, 2, 3, 4. So a sub 4 in this case is 16. Now, in the same way, let's take a look if n equals 1. So that means instead of looking for 4 here, I'm looking for 1. So again, a sub 1 looks like that. So a sub 1, if I'm looking at this series, is just the first term. So what is the first term? The first term is 1. So when I'm writing these terms, it's simply just telling me which one am I looking at. I'm looking at the fourth term, I'm looking at the first term, and so on. Now, with that being said, we come up with rules to define our sequences many times. So here I have a rule. I have a sub n equals 4n plus 1. And so if I want to list the first terms, so what I would start with a sub, we'll stick with this, a sub 1. Let's get this little format right. There we go. A sub 1, and so let's fix that, would equal 4 times 1 plus 1. Which we know if we do that out is 4 plus 1, which equals 5. So that is a sub 1. Now if I want to continue this, so let's go ahead and copy that. So I'm looking for the next 4 terms. So the next one here we know would be 2. So the next term would be if I replace this with a 2. So 4 times 2 is 8, plus 1 equals 9. So that is the next term on my sequence, and then I'll do that twice more. So let's see, let's drop those down here. So do that twice more, so a sub 3. A sub 3 simply means I replace the n with 3. So if I do 4 times 3 equals 12 plus 1, so that would be 13. And doing the same thing to get a sub 4, I now replace the one with a 4, so that gives me a value of, let's see, 16 and 17, and I just realized there is a mistake up here. This is not 13 or 14. It is 13 because we know that 4 times 3 is 12. I got a little ahead of myself. So that's how we find the first 4 terms, is I take my values 1, 2, 3, and 4, and I replace them in the rule. So let's do the same thing for this other one. I'm going to go ahead and copy that over here. So a sub 1, now this time I have a different rule. So if you remember, we have this thing called factorial. Now factorial, just as a refresher, simply means take all those numbers. So in this case, it would just be 1 times itself gives us 1. Now that's not very helpful in explaining what factorial is, so let's look at 2 factorial. 2 factorial is simply 1 or 2 times 1, which equals 2. So that is our a sub 2. A sub 3, in the same way, would be 3 factorial, which 3 factorial is 3 times 2 times 1. If you haven't picked up on it yet, factorial simply means take all the numbers smaller than 3 and multiply them together, and we're sticking with those whole numbers. So that would be 3 times 2, which is 6, times 1, which again is 6. So to find our last term, 4 factorial, I would take 4 times 3 times, oops, that is not a 4. 4 times 3 times 2 times 1, which is 24. So these are the first 4 terms in our sequence. Now we have this thing called the series, or a series. A series is the sum of all the terms in a sequence, meaning I just take all of those values and I add them together. Nothing crazy. So for example, let's say I have this sequence 1, 4, 9, 16, 25, so those perfect squares here. Now what that means, or for the series, is if I were to add them all together, 1 plus 4 plus 9 plus 16 plus 25, that is the associated series. Now to write out a series, we have this thing called summation notation. Now this thing here, this is what is called sigma, and let me go ahead and draw a little arrow here. So sigma is that Greek letter right there, that kind of E looking thing. So the E looking thing, that is called sigma, and what it does is it represents summation notation, meaning I'm going to add a whole bunch of things together. So let's talk about how this works. Let's scoot those over here. So to do this particular summation notation, what I'm going to do is I'm going to basically do the same thing I did when finding the terms in the sequence, but in this case I'm going to add them. Now here's how this works. So let me go ahead and put an equals. What I do is I first start with n equals 1. And what I do is I plug in 1 into the equation. So it'd be 1, let's make it bigger. There we go. Which in this case would be, let's fix that. In this case would be 1 and then squared. So unfortunately there's no keyboard shortcut for this, so I'm gonna have to live with me typing for a moment. Plus. Now this is a counter, so what I'm gonna do is I'm gonna count all the whole numbers between 1 and 5. So the next one here, let me go and just copy that and make it easier on myself. So the next one in the series would be 2 squared, because I go count up, the next number after 1 is 2, so I do 2 squared, and then I add again, but this time instead of a 1, I'm now going to replace it with a 3, because I go from 1 to 2 to 3, so if you're playing along at home guessing what's going to come next, well the next thing that's going to come along is a 4 squared, because I'm going to go to 4. And then the last term is going to be a 5 squared, because I'm going to count all the whole numbers between 1 and 5. This is my starting place and this is my stopping place. I'm not going to keep going after I plug in 5. And so from here, this is where I would plug in those values. So that would be 1 plus 4 plus 9 plus 16 plus 25, which we already found out, or we were looking at just a moment ago. And so let's see, that would be 10, 14, 30, that equals 55. And so that is how you evaluate a series using sigma notation. You are going to use this added counter. You're going to start at 1 and then go to 2, 3, 4, all the way up until 5, and then you stop. and then add them all together. So let's evaluate this particular sigma notation. So in this case, the rule is pretty simple. All it does is it say take k. All right, so k starts at 1, so I'm going to take 1, and then I'm going to plug in the next numbers all the way up until 6. So this says 1, the next one is 2, the next is 3, the next is 4, the next is 5, and then the last here is 6. And so all I'm going to do is I plugged in those values 1 through 6 into k, and so I'm just going to add them together. So let's see, that is 3, 6, 10, 15, and that would be a value of 21. Now let's look at another one. So here I've got the summation from I is 1 to 8, and my function here is 5. Now if you notice here, I really doesn't affect 5. It is a constant function. So what that means here is I'm going to take 5. When I plug in 1, well, when I plug in 1 it changes nothing because there is no I. It's just 5 plus. Then I go to 2, so when I have 2, it's still going to be 5. And I'm going to do that 8 times, because that would be starting at the values 1, 2, 3, 4, 5, 6, 7, 8. So I do that 8 times. So that would be 3, 4, 5, 6, 7, 8. And so I add all of those together, and it gives me a value of 40. So I'm counting 8 times because I start at 1, go to 8, and I'm counting all the whole numbers in the middle. Now, let's try this one. So let's express the sum using sigma notation. So if I look here at this particular function, let's try and see what am I counting by. So I see that from here to here, this is a +1. If I look from here to here, this is also a +1. And notice here, all right, so this isn't very exciting. It's just adding 1 every single time. And I'm just going all the way until I get to 37. So here's what I'm going to do. I'm going to use sigma notation. Let's see, there's sigma. And so I'm going to use the variable n. It doesn't matter which variable you use. You can use I, j, k, whatever. It doesn't matter. So I'm going to start my count at 1. And now if I notice here, I'm just using those numbers, 1 to 37. So my rule here is n, meaning I'm just going to take the numbers and plug it in. So it'll just be 1, 2, 3. I'm not going to do anything to them. And so here I'm counting. If I notice, I go from 1 to 37. So my start is 1. That means my end, let's see if we make it, is 37. And that's my rule. It means plug in all the numbers between 1 to 37 and add them all together. And that's what that says. So that ends our brief tutorial on how to use sigma notation. What are sequences? They're just a group of numbers that follow a pattern. What is a series? Which is the sum of a sequence, meaning we take one, we add it all together. And how to use sigma notation. Remember, these are counters, so I'm going from 1 to 37 with all the whole numbers in between. Hope this helped. Your homework is posted online.